The casting alloys in dentistry are of two types: noble metal casting alloys and base metal casting alloys. Hi, I am Dr. Rashid Hassan, and in this lecture I am going to talk about base metal casting alloys in dentistry. The base metal casting alloys contain no precious elements like gold, silver, platinum, palladium. So the base metal casting alloys contain the metals which are other than the noble metals. And the most commonly used base metal casting alloys in dentistry are of two types: nickel chromium alloys and cobalt chromium alloys. The difference in the application of these two base metal casting alloys is that the nickel chromium casting alloys, it is used for the crown and bridge casting frameworks, also including the porcelain fused to metal restorations, whereas the cobalt chromium casting alloys, it is used for the partial denture framework castings. First, let's go through the chemical composition of these base metal casting alloys as specified by ISO standard for the dental base metal casting alloys. First of all is the nickel chromium casting alloy. Nickel chromium casting alloy has nickel, chromium, molybdenum and beryllium. Nickel is the main constituent, whereas the chromium should not be less than 20%, molybdenum should not be less than 4%, and beryllium should not be more than 2% in the chemical composition of the nickel chromium casting alloys. The cobalt chromium casting alloys consist of cobalt, chromium, nickel, molybdenum and mild traces of beryllium, silicon and carbon. Cobalt is the main constituent, whereas chromium should not be less than 25%, nickel ranges from 0 to 30%, molybdenum should not be less than 4%. The cobalt and nickel are hard and strong metals, whereas the main purpose of chromium is to further harden the alloy, and it also imparts the corrosion resistant property by passivating effect to the cobalt chromium casting alloy. Now let's talk about the manipulation of base metal casting alloys. The fusion temperatures of nickel chromium and cobalt chromium alloys, they vary with the composition, but generally the range of the fusion temperature is 1200 to 1500 degrees centigrade. The two methods used for heating the base metal casting alloys are: number 1, acetylene oxygen flame, and number 2, electrical induction furnace. Well, in case of the acetylene oxygen flame, the ratio of oxygen to acetylene must be carefully controlled, because in case of excess of oxygen, the oxidation of alloy can occur, whereas in case of the excess of acetylene, it may cause the metal carbide formation, leading to embrittlement of the alloy. So that's why the second method, which is the electrical induction furnace method, is more preferred because of more controlled conditions. The investment material used for the base metal casting alloy must be capable of maintaining its integrity at such high casting temperatures, and for this reason silica bonded and phosphate bonded investment materials are favored, and out of these two, phosphate bonded are more preferred. The gypsum bonded investment materials, well, they are not used for base metal casting alloys because they decompose above 1200 degrees centigrade, forming sulfur dioxide, which may get absorbed in the casting. Now let's compare a few properties of these two base metal casting alloys. First of all is the density. Well, the density of both nickel chromium and cobalt chromium casting alloy is same, which means that they are equal in weight. Secondly is the fusion temperature. Well, the fusion temperature of nickel chromium casting alloy is as high as 1350 degrees centigrade, whereas the fusion temperature of cobalt chromium casting alloy is as high as 1500 degrees centigrade. So the cobalt chromium base metal casting alloy has slightly higher value of the fusion temperature as compared to the nickel chromium. Comparing the casting shrinkage of the base metal casting alloys, the nickel chromium casting alloy has the casting shrinkage of 2%, whereas the cobalt chromium casting alloy has 2.3%, so they are almost similar. Comparing the ductility of the base metal casting alloys, the higher range in case of nickel chromium casting alloys suggests that more forces can be applied while burnishing the nickel chromium casting alloy, whereas in case of cobalt chromium casting alloy, the alloy may fracture in cases where the adjustments are required. Next is the strength of the base metal casting alloy when a tensile force is applied. So the tensile strength of nickel chromium casting alloy is 600 megapascals, whereas the tensile strength of cobalt chromium alloy is 850 megapascal. So cobalt chromium has more value of the tensile strength as compared to the nickel chromium. Comparing the proportional limit for the base metal casting alloys, the proportional limit for nickel chromium and cobalt chromium is 500 and 700 megapascals. The higher values of the proportional limits suggest that both these base metal casting alloys has the ability to withstand stresses without deformation. Talking about the modulus of elasticity, which determines the stiffness of a material, both nickel chromium and cobalt chromium have equal values of modulus of elasticity. Lastly, comparing the hardness, which is the property of a material to resist the indentation, the Vickers hardness number for nickel chromium casting alloy is 300, whereas the Vickers hardness number for cobalt chromium casting alloy is 420. Both the nickel chromium and cobalt chromium base metal casting alloys are difficult to polish, but they retain their polishing throughout the service due to the higher values of the hardness number. So this was a brief lecture about the base metal casting alloys. Do leave your feedback in the comments below. I hope it was helpful. Thank you very much. Take care.